Hi everyone, so we're about to start. Um, we hope you're doing good. Today we're about to do to you the webinar of metagenomic analyze into Constellab universe. For those who were present at the first session, this is not like the first session, so we will not do a comeback about how to use the universe, but we will directly show how to do metagenomic analyze into the Constellab platform. First of all, Thibault will show you everything, and after what we will have a short question session. You can ask your question in the chat section, and I will be there to answer to you. Thibault, let's go.
Okay, hello everyone, welcome to the webinar focused on metagenomic data analysis. So firstly, I assume that everyone has a basic knowledge of metagenomic data analysis. So we can start. I'm going to share my screen. Everybody can see my screen? I suppose yes. So welcome to Constellab platform. On this page, as you can see, we have multiple sections. So the section project, digital lab project, and team project. So today we will focus on bioinformatics project. So this is a hierarchical project. So inside we have multiple sub-projects, and today we will focus on CSS data analysis. On this page, as we can see, we have also multiple sections. We have report section, experiment section, and document section. In document section, we can put different type of document, and I will open one. This is a document to present you the plan of the webinar. So the main idea of this webinar is to show how we can easily analyze metagenomic data in Constellab. So more especially, we will focus on reproduce the analysis and results taken from articles published in 2019. So for the context, for the biological context, these articles talk about the diagnosis of gut microbiota in population of Parkinson patients. So there are 152 fecal samples collected from 80 patients and 72 LC control. So how we process the idea in the webinar, there are two big sections. The first section will focus on the basic pipeline to analyze CSS metagenomic data. So in this section, we have multiple steps. The first step will be on data processing. The second step it will be focused on diversity and rarefaction metric analysis. And the last section will be focused on result analysis. In the second part, we will study the functional annotation analysis, and we have two sections in this part. So data arrangement and statistical analysis and visualization. And at the end, a question moment. So this is the plan of the webinar. So if I come back to the previous page, we'll go deeper on this webinar, and we will start with a first experiment. We will connect directly on the lab. And on this lab, we have multiple sections: experiment section, data box section, view box section, and report section. Experiment is to do experiment. Data box section is to store data, raw data, and result data. And view section is to visualize the results. And report section, as we can see, is to write and share report. So if you start with the beginning, with the first experiment, what we have? we have input. The first input is a FASTA folder, FASTQ file folder, and a metadata file. The first step in this experience is to check the quality of the sequencing. So we have a first task, and this task is dedicated to check if the sequencing is a good quality or not. In this task, if I enter deeper in this task, in the configuration, we have only one parameter, and this parameter is the type of the sequencing. So for example, you can choose single end or per end. In this study, we choose per end sequencing. So what we obtain different results. So the first results is two plots, one plot for reverse read and one plot for forward. So as you can see on this plot, we had in y-axis the Fred score and in x-axis the base position. And if this plot is interactive, and we can zoom on a specific section, specific position, to observe the quality of each position. The idea of this plot is to determine the quality and filter the read based on a specific threshold for reverse and forward sequencing. So after this step, we have also a second input. This second input is a folder, and inside this folder, we can retrieve the read choose for the next analysis. In the next analysis, the goal is to infer ISV. For that, we have 4 parameters in this task. The first parameter is the number of threads, is useful for computation because this task asks a lot of computation time. So we can choose the number of core in your processor. In this case, I choose 4. And we have other parameter, truncated forward read size, truncated reverse read size, and 5' hard trimming read size. These 2 first parameters is determined with the previous analysis determined by the user. So this task do denoising and raw data and produce the ISV tabular. In output, we have different type of output. For example, we have one output to visualize which read we choose based on filter and separate the read, chimeric reads and useful reads, for example. Again, this plot is interactive, so if you pass your mouse on a specific box plot, you can obtain statistics. We can obtain also other results, other output. This output is, for example, a tabular. We have for each sample the results of the number of reads we conserve. And the last output is a folder, and inside this folder we have the result of the analysis. I forget to mention that these 2 tasks are based on Shimde package. Maybe you already know this package is a very familiar package to treat metagenomic data. Okay, this is the first experiment. The second experiment is to determine and quantify the count of each species at different granularity, family, genus, etc. So we can go directly on this task. So for the input, we get the folder obtained in a previous experiment, and we connect this folder to 2 tasks. One task to determine the taxonomy diversity, and one other task to determine rarefaction, to do rarefaction analysis. Again, each task has different output. For example, if I click directly here, we obtain different table, and in each table, we calculate the alpha diversity matrix for each sample. Okay, it's useful, but for example, you can directly create a plot to obtain a better visualization. For example, I don't know, a box plot visualization. Okay, we have a different, again, we have a different output. We obtain the table. So the count for each granularity, so phylum, class, order, etc. This is the most important output, of course, for the next step. For rarefaction analysis, the same, we have different output. And for example, if I choose this output, we obtain the rarefaction curve, and we can determine which profondeur depth for the sequencing is necessary to obtain a good quality for diversity analysis. Okay, this is a second experiment. Maybe I forget to describe the different parameters. For example, for this task, we have 3 parameters. The first parameter is a threshold. The second is very important, is the database chosen. For example, we have multiple choice. Here, to reproduce the result of our articles, I choose Green Gene database, but of course we can choose other database depending on what you want. And we have you have the parameters fed to put the number of core of your processor. Okay, next. The last part of this first section is how we can analyze basically the result obtained in a previous experiment. So we have a third experiment called result analysis. In this experiment, the goal of this experiment is analyze results at the family level between the two groups. So patients with Parkinson and patient without. So as we can see, we connect a lot of different tasks. Basically, the first task is data pre-processing, result pre-processing. So in the first task, for example, I aggregate row. In the second, I scale the row. Here I choose the scaling function is percentage. And at the end, I want to, for example, compare the two distribution, and I use Mann-Whitney test. Of course, we can use other tests. We have other possibility in Constellab. This is the subject of the next webinar in the next months. So if I want to visualize the results after the test, I obtain different table. I don't enter in the detail, but basically it's the result of the test. So if I want to visualize the results, for example, I want to create a plot. Here I create two different possibility to create a plot. The first possibility is use at Gencovery, we call that a smart interactive plot. Basically, is we write a message like ChatGPT, in fact, and we ask, for example, here I ask to produce a heat map using the contingency table to visualize the results. So it creates a code, of course, but it creates directly also the visualization. Here we are at the family level. So for example, we can see easily, it's interactive again, but we can see easily between the two conditions, this family are significantly different in the two samples with this family. This is one of possibility. Another possibility is use a lav task. Lav task, you can put directly your code inside. And it can be useful, for example, to obtain a very beautiful figure for a report or an article, for example. And again, we obtain the results, and the result is a bar plot. And here we can see in the two conditions, the distribution of each family between the condition, LC condition and Parkinson condition. Okay, this is the three experience for the first section. The second section is will focus on functional analysis prediction. What is the goal of this section? Maybe you already know, is predict pathway metabolic significantly different between two conditions, and obtain a visualization to analyze the data. Of course, this task is a prediction task, so the result is not perfect, but is very useful to analyze data. So in this experiment, we have two tasks. The first task is process the data. We have two inputs, the FASTQ folder and a table obtained with the first experiment in the previous section. The output of this task is a tabular, a folder, and in the folder we have the mapping between KG annotation and the different sample and reads. This task is very useful for the next task because using this task we can do statistical analysis with this task, for example, and obtain the results which metabolic pathway is enriched in one condition versus another condition. For example, if you go to one of the output, this output is a PCA of the result, and as we can see, between conditions we have some sample clearly different than other sample between condition and other condition. This is one of the visualization. Is useful, but is not the most interesting output. If I go in this resource set, in this folder, I have three different outputs, and the most useful, I think, output is this plot. Not here. So if I zoom in on this this plot, we can see for different metabolic pathway the enrichment between two conditions. For example, if I choose a good example, I don't know, for example, the metabolism amino acid metabolism, we can see a significant difference between the two samples, or two conditions. On this plot, if I zoom out, up. On this plot is based on the top 20 of metabolic pathway enriched differently in two conditions. Of course, in each task, we have different kind of parameter. For example, for this task, we have the method to calculate the p-value. We need to write the reference column to compare to the reference group, etc. Well, now we have all the experiments. All the results are stored in the data box. We can retrieve all the results here. We can retrieve all the view here, all the tagged view here. and we can create a report. Here I create a report to analyze the data and visualize the data and compare the results with the results proposed in the articles. The good news, we retrieve the same results, and for some tasks, we retrieve better results than the articles. So it's nice. So here I sum up all different methods I use and the result I obtain. For example, here is a box plot I show you before. The nice things is you can put directly the interactive plot inside the report. So if you want to manipulate this graph directly in the report, you can. For example, if you want to zoom on the specific part. So we can retrieve, as I can see, all the different inputs. The nice idea of this report is you can share this report. So for example, you want to share this report directly with other colleagues without use experiments or a technical part. So it can be useful, for example, to share the report between different teams in your company. Okay, I want just to talk about a nice option in Constellab. The nice option is this option. You can synchronize the experiments and the report with your space. So if I come back to the space, Metagenomic says this here, you can retrieve directly the report, the experiment, and like I say, the document. So this icon means the experiment is validated. So the experiment can't be changed. So it's very useful because it fixes the project, and you can, for example, once the experiment is validated, you can be sure to obtain each time the same results. You can retrieve the report, and we have a section here, for example, with a chat, and you can communicate with the different members of the project to discuss about different subjects. Okay, I think I talk about all the stuff. If you have a question, don't hesitate. Thank you for hearing me.
Thank you, Thibault. Thank you, Thibault. So if anyone has question, you can request it in French or English, as you want. We found also the link to the first section of webinar. So, je vais activer ton micro dès que tu réponds. Hi, thank you for the presentation. Is the report in some way pre-filed, or is it a blank page to start with?
In Constellab, we have two possibilities. So you can start with blank page, like I do, for example, for this presentation. But we have also a live task to pre-configure the report. And for example, if you do the same analysis and you want to automatize or semi-automatize the report, we can do it. So it's a specific task, and you can also pre-configure your report.
Merci.
Okay, for the second question about the green gene choice for the database, of course not. Generally, we prefer RDP database, but to reproduce the same results of the articles, I choose green gene database. We have multiple possibilities, but of course we can choose other database. Okay, for the next question, comment importe-t-on les données? C'est vrai que je ne l'ai pas mentionné parce que c'était expliqué dans le premier webinaire, mais si je repartage mon écran rapidement, je peux vous montrer directement ça. Donc, on se connecte au lab. Et si on va dans la data box, ici, vous avez justement 3 icônes, et notamment une icône où vous pouvez uploader justement soit des fichiers, soit un folder en entier. Donc, si vous cliquez ici, justement, vous pouvez directement uploader des fichiers. Alors, ça peut être des fichiers, des raw data, donc par exemple des CSV, des fichiers Excel, etc. Ou directement des fichiers prêts à l'emploi, on va dire. Donc, des fichiers pré-traités. OK.
Where's the data stored? Is there on-premise installation? Is it on the cloud?
So you have multiple possibility with Constellab. So you can choose on cloud. So you need to determine before which cloud you want, Azure, etc. We have different possibility, OVH, etc. But you can also install Constellab in your own installation, so on-premise solution, and the data will be stored in your installation, of course.
Emmanuel Presta qui répond « Ok, mais les données de Shotgun ne sont pas stockées sur mon terminal, mais sur un serveur. » Par rapport à la question d'avant.
Ouais. Alors, pour répondre à cette question, comme je l'ai dit, on a plusieurs solutions. Si elles sont stockées sur un serveur qui est, par exemple, au sein de votre compagnie, on a la possibilité, avec la version on-premise, de connecter le lab et l'environnement Constellab à votre serveur et du coup, conserver le fait que vous stockez vos données sur un serveur et faire les calculs sur Constellab. Bien sûr, les calculs se feront quand on choisit l'option on-premise avec la puissance de calcul que vous avez sur votre serveur. Donc ça, on n'a pas le choix. C'est l'avantage du cloud où on peut choisir différents types de machines, soit des machines puissantes ou pas.
Thibault, est-ce qu'on peut avoir d'autres bases que GreenGen?
Oui. La question est oui. Si je repartage mon écran et que je reviens sur l'expérience justement où on effectue l'inférence des taxons, ici, vous avez un paramètre où vous pouvez choisir les bases de données que vous souhaitez. Alors ici, on a 4 choix, hein. Ce n'est pas un choix exhaustif, mais oui, on peut choisir différents types de bases de données sur lesquelles on veut entraîner nos jeux de données. Alors, qu'en pensez-vous du shotgun par rapport au CSS? Alors, c'est une question assez généraliste et assez spécifique à la fois. Pour moi, ces 2 types d'analyses répondent à deux volontés différentes, 2 résultats différents. C'est-à-dire que le CSS, on va obtenir une information qui est combien on a d'espèces dans un échantillon ou entre deux conditions. Donc, une sorte de comptage, mais ça sera uniquement du comptage d'espèces ou de familles, ça dépend de la hiérarchie qu'on veut. Au niveau du shotgun, on va un peu plus loin, puisqu'on séquence non plus que les rRNA, mais aussi les autres gènes. Et du coup, pour le shotgun, on va avoir une information différente qui va être justement plus, on va dire, plus précise, mais plus généraliste aussi, sur les différents gènes qu'on séquence donc, au niveau des différents organismes. Donc pour moi, elles sont complémentaires en fait. À noter que justement sur le CSS, maintenant c'est assez démocratisé, donc il y a une histoire de coût aussi.
Comment vous vous différenciez sur ce type d'analyse par rapport à des acteurs déjà en place, son ID?
Alors, je ne connais pas bien cet outil-là, mais ce que je pourrais vous dire, c'est que quelle est la force de Constellab? La force de Constellab, elle réside dans le fait d'avoir à la fois un espace collaboratif et un espace d'analyse. Ça, c'est un premier point. La deuxième force, elle est aussi qu'on peut à la fois être non expert, c'est-à-dire utiliser, si je reviens sur un type de pipeline, juste brancher nos données à des tâches et en mode clic-bouton. Donc, on n'a pas besoin de programmer, de connaître le Python ou autre langage pour faire l'analyse. Ça, c'est une des forces. Et enfin, on peut mener un projet de A à Z sur Constellab. Donc, encore une fois, je ne connais pas le Cosmo ID, hein, mais pour moi, c'est ça les forces et c'est ça qui est différenciant par rapport aux autres outils. Pour répondre à une question qui est passée, qu'on a loupée, I'd like to talk about the cost and it works as a subscription. Could we have an idea of the price? For this question, I advise you to contact the client success page, and we have all the information. And for example, take a rendezvous to obtain more information about a subscription. You can, if I go on the dashboard, if you create an account on Constellab, you have the possibility to have a lab for 1 week with a certain time to use and to try different pipeline here. So free trial version.
I take this opportunity to tell you that if you want to know more or to try the platform directly by yourself, but with an expert, we also propose some workshops and formation. Just have to request it on the contact page on the website. Waiting for the last questions. So compared to Cosmo ID, Constellab is open to a broader range of application.
Yeah, of course, I don't mention it, but here we focus on metagenomic CSS data analysis, but we can do a lot of things. For example, a dynamical system analysis, RNA-seq analysis, and multiple other things.
Well, thank you, everyone. Soon we will tell about our next webinar session, which will be about data analyze and more specifically about omics data. Don't forget to follow us on LinkedIn and to watch our website to keep informed about what's coming next. To know more or to try the platform, we also propose workshop information. You just have to send us a request on the website. Thank you, everyone.
Thank you.